So let's do this problem from Hibbeler, one of the suggested problems from Hibbeler. It's problem number 9.9. It's a very simple problem statement. Just determine the centroid or center of mass. So of this kind of strangely shaped object. So we're assuming here that it's a three-dimensional object. You're just seeing a cross-section of it. So we're assuming the thickness is uniform. And we're also assuming that the material is uniform. Okay, so anytime you have this kind of a problem, the strategy is to break this complicated thing into simple shapes, right? And then you figure out the center of mass of each of the shapes, and then you add up, you find the center of mass of the whole thing together by using the formula for point masses. So let me just summarize that, how that works. So here's your kind of summary of this kind of problem. Break it into simple shapes. I reduce each shape to a point mass located at the center of mass of each of the shapes, and then I add up and find the center of mass of the whole thing using these formulas for the center of mass from a system of point masses. So the way I like to do this, well, we have to think first about what shape should we use. I mean, there's kind of a lot of possibilities here. I'm going to do one that is maybe not so obvious, but turns out to be kind of nice, is I'm going to think of this as a large square, so a big rectangle here, which has a center of mass at the center of the rectangle, of course. I'm going to call that R. And then you see that rectangle has had two holes cut out of it. So I've got a hole from this quarter circle, so I'm going to call this thing Q. So there's a hole at the center of that quarter circle, and there's also a hole somewhere because of this triangle here. I'll call that T. So I'm thinking about it as three masses, or three shapes: a big rectangle, a triangular hole, and a quarter circular hole. All right, so we're going to work with those. So let's go to the next slide. I'll show you a systematic way of going about this kind of problem. Okay, so to solve this kind of problem, I like to make this table. The table helps me keep me organized so that I don't get lost in the math. So what I'm doing here is I've written down each of the shapes: the rectangle, the quarter circle, the triangle. I need to determine the x and y components of the center of mass of each of those shapes and enter them into those first two columns. And then I also enter in the area of the shape in the third column. And I'll deal with this fourth column later, so I'm just going to fill out the first three columns for those three shapes. So just because I don't really like dealing with numbers that much, I'm going to write L is equal to 1 inch. So L, I'm going to use the letter L instead of writing 1 inch. Okay, now remember, all of these coordinates are measured relative to the origin, which is in the lower left-hand corner there, 0, 0. So let's deal with the rectangle first. That's the easy one. The rectangle clearly has a center of mass at the center of the rectangle, and the rectangle is 10 inches long and 6 inches high, right? And so since L is 1 inch, it's 10L long and 6L high. The exact center of that is going to be 5L in the x direction and 3L in the y direction, right? That's where the center of mass of the rectangle is. The area of the rectangle is just 10L times 6L. So 10L is the length times the width, which is 60L squared. Right? So that's what I put into this entry there. And again, I'll leave the third or the fourth column blank, so I'll just enter those three. Now that's the easy one. Now I got to do something a little more complicated, which is to deal with the triangle and the quarter circle. So I'll do that on the next slide. Okay, so now we need to do the more complicated pieces of the quarter circle and the triangle. So let's focus on the quarter circle first. You need to look up, if you don't know, where the coordinates of the center of mass of a quarter circle are. So here's the figure that I found. If you look it up, you find that you need to go, measured from the corner here, sort of at the center of the circle, you need to go a distance 4r over 3 pi in the x direction and 4r over 3 pi in the y direction. R is the radius of the circle. So we need to apply that to our case. R is a hole, right? And it looks kind of like this. And so our center of mass will be somewhere here. The radius is 3L, right? Remember, L is 1 inch. And so that means that I need to go from this sort of corner here. From here to here is a distance of 4r, which is 3L, over 3 pi, right? Which is 4L over pi. And similarly, this distance here will be 4L over pi. Okay? Now what we need to enter into the table is the coordinates of the center of mass of that thing measured from the origin down here in the lower left corner. So how do I get there? I need to go all the way to the edge of the rectangle, but stop short by a distance of 4L over 3 pi. Right? So this distance here is going to be the whole length of the rectangle, 10L, sorry, not 4L over 3 pi, just 4L over pi. 10L minus 4L over pi. Okay? So that's what I'm going to enter into this table here. I will pull out an L, 10 minus 4 over pi. And the same idea in the y direction. I need to go the whole height, which is 6L, but then subtract 4L over pi. So it's going to be L times 6 minus 4 over pi. Okay? Finally, the area of the quarter circle is easy enough. It's 1/4 of the area of the whole circle, which is pi times r squared, and r is 3L squared. Right? So that is 9 pi over 4 L squared. Now, you have to be careful here. The one thing that's important to remember, and it's very easy to forget this, is that it's a hole, okay? So a hole means that it has negative area and negative mass. So I put a minus sign here. So anytime you're dealing with a hole, your area is a negative and your mass will be negative, okay? So now let's go on to the circle. The triangle. Okay, so now we need to calculate the center of mass of the triangle. You need to look up the center of mass of the triangle, and if you do that, you see that this is what it looks like. It looks like measured from the corner where the right angle is, you go 1/3 of the way along the base in the x direction and 1/3 of the way along the height in the y direction. So what does our triangle look like? Remember, our triangle, we're doing this triangular hole here, that piece there. So our triangle looks kind of, let me rotate it, it looks like this. Okay, it's an equilateral triangle. It has a length here of 3L and a height here of 3L also, right? So where's the center of mass of that? I go from the corner 1/3 of the way along the base. So it's going to be somewhere here. And this distance here will just be L, right? And 1/3 of the way along the height. So this distance here will also be L. Okay? Now we want the xy coordinates of that measured from the origin, which is down there, right? 0, 0. So I have to go L in the x direction, and in the y direction I have to go all the way up to the top of the rectangle, but then back by L, right? So the total all the way to the top of the rectangle is 6L minus L, right? So it's going to be 5L here. What's the area of the triangle? Easy enough, right? It's 1/2 the base times the height, 3L times 3L. So that's 9L squared over 2. And I put a minus sign again because this is a hole, right? There's a triangular hole cut out of this rectangle, so that's why there's a minus sign there. Okay, we've got basically everything done except for the last column. So now let's work on that last column. Okay, we've got the first three columns complete. Now we just need to fill out that fourth column. So that's the area of each shape divided by the total area. To do that, I need to first compute the total area, so I'll just add up everything in this column here, right? So I'm going to add up everything in this column to calculate the total area. So a total is just add everything up. There's an L squared everywhere, so I'm going to have 60 minus 9 pi over 4 minus 9 halves, right? And just to clean it up a little bit, I'll pull out a factor of 4. So L squared over 4. 60 times 4 is 240 minus 9 pi minus 18, which is L squared over 4 times 222 minus 9 pi. Now let's just do the first one. For example, what's the area of the rectangle divided by the total area? It's 60 L squared. That's the area of the rectangle on the top, and the bottom is L squared over 4 times 222 minus 9 pi. And the L squareds will cancel. And I'm going to get here 240 over 222 minus 9 pi. Okay, so that's what I'll put in into that first entry there. Now the other two are similar, so let me just show you what those look like without going through them in detail. So there you have the others for the quarter circle and the triangle. So now we have the full table filled out, and now all we have to do is multiply a couple of numbers together in this table in order to finish the problem. So we'll show you how to do that on the next slide. Okay, so the next step, if you go back to the first slide where we had planned out the solution, is to now use the formula for point masses, which I've written here. So we've reduced each of those simple shapes to a point mass, and now I just need to use this formula. So the way it works, I think the easiest way is to see what happens if you distribute this m total through to each of these terms. You end up with something that looks like this. The mass of the rectangle divided by the total mass times the center of mass of the rectangle plus the mass of the quarter circle divided by the total mass times the center of mass of the quarter circle, and so on. Now, what is this? The mass of the rectangle divided by the total mass. Remember that if the thickness and material are uniform, so they're all made from the same material, how would I get the mass, say, of the rectangle? It was the density of the material times the volume of the rectangle, and the volume of the rectangle is the area of the rectangle times the thickness of the material, so T is the thickness. And the total mass, of course, is just going to be the same density of the material, total area, times the thickness, right? So you can see that if I divide these two equations, everything cancels out here. And so the mass of the rectangle divided by the total mass is equal to the area of the rectangle divided by the total area. So in other words, the mass is proportional to area. That's the whole point of using this quantity here, right? So I can rewrite my formula now. XCM is area of the rectangle divided by the total area times the center of mass of the rectangle plus area of the quarter circle divided by the total area times x of the quarter circle plus the area of the triangle divided by the total area times x of the triangle. And now it's easy, right? Now all I have to do is just read off those things from the table to compute that to compute the coordinates of the center of mass. So on the last slide, we argued that we could use this formula for the center of mass, using the ratio of the areas instead of the ratio of the masses, or those are the same. And so now we have this nice organized table. We just need to read off those values. So in red, I'm going to take the area of the rectangle divided by the total area, that's this here, multiplied by the center of mass of the rectangle there, right? So I will write here 240 over 222 minus 9 pi times 5L, right? And then I will do the same thing for the quarter circle here, multiplied by the center of mass of the quarter circle, and then the same thing for the triangle, this entry multiplied by this entry. So let me do that very quickly. Okay, there we have it. So let's simplify it. Everywhere I've got an L, 222 minus 9 pi. And then here I've got 5 times 240, that's 1200, minus 90 pi plus 360 minus 18. Sorry, just a small mistake, 36, not 360. And then let's simplify that whole thing. There you go. And then remember that L is equal to 1 inch, so you can plug it into your calculator to get the result. 4.828 inches. Okay. Remember, that's measured relative to the origin down here. So it's 4.828 inches to the right of that origin there. That's the X position. Now we need to do the Y position. So I'll do that on the next slide, and that will finish the problem. So there are the results for the Y direction. We do exactly the same thing as we did for the X direction, just making sure to use the Y column instead of the X column. And this is the answer, right? 2.562 times L. So our Y components, coordinates of my center of mass are 2.562 inches. So this is the answer to the problem for the X and the Y. You should take a moment to think about, does this make any sense, right? So, for example, where do we expect the center of mass to be? Well, if it was just a full rectangle, it should be at exactly in the middle, which would be a coordinates of 5 inches and in the X and 3 inches up, right? Now, some pieces of the rectangle have been cut out, right? So we had these pieces cut out. So there's more mass on the bottom of the rectangle than on the top. So we expect that the center of mass should be on the lower half of the rectangle, right? So it should be lower than 3, and it is, right? So the Y coordinate is below 3, so that makes physical sense. How about the X coordinate? More mass has been cut out from the quarter circle here than the triangle, right? Because the quarter circle has a bigger area than the triangle. So that means we expect the center of mass to be on the left side of the rectangle, right? So it should be just by a little bit, because the quarter circle is only a little bit bigger than the rectangle. And so we expect the center of mass to be on the left side of center of the rectangle, right? So it should be somewhere less than 5, and it is just a little bit less than 5, right? So that makes perfect sense, at least from our intuition, where should it be. So it gives us some confidence in the result. All right, so it's kind of a tedious problem. I hope that you get the idea of how to set up this table. Once you start setting up the table, it's sort of a very simple prescription of how to get the answer. It just takes a little bit of time to get there. So I hope you found this problem useful, and good luck with similar problems.